section 6.1, trig functions of acute angles. Okay. So again, if we have a right triangle, we've been talking about this to some angle. If this is my angle that I'm using, to this angle, this side is going to be opposite to theta. This side is going to be adjacent to theta, and this is the hypotenuse of a right triangle. So our definitions now, even though we've been using them for a few sections, if you think about it, right triangle definitions for trig functions, sine theta is going to be opposite over hypotenuse. We've been using y over r. Well, this would be our y value as we go up, y over r. Well, it's going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then we have the reciprocal functions. So I think a couple sections ago I mentioned it. It's SOHCAHTOA. This is a French Indian cure for athlete's foot. It's sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So as we go through, this is one of those harmonic devices that you can use to help remember what sine is. So again, it's sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you have to be able to spell it right. So this is going away from your y's, x, and r's, but you can still do that. And when we were doing y, x, and r, I was also doing y opposite over hypotenuse for sine, cosine adjacent over hypotenuse for cosine, and tangent is that opposite over adjacent. So if we are looking, so here's our definitions, but again, this would be, this y value, if this was our triangle, this is going to be our opposite. This is going to be our adjacent. And this is going to be our hypotenuse. So, and this angle is theta. Now, if we were going to a different angle, then that would change things. If we were using this angle, this would be opposite, this would be adjacent, and this would still be our hypotenuse opposite that 90-degree angle as we're going through. So you can still use y over x, but we're going to be getting into other triangles away from our xy axis. So I think it's helpful to remember it as opposite, hypotenuse, adjacent from some angle as you're going. And remember how to spell SOHCAHTOA, that French Indian cure for athlete's foot. Go SOHCAHTOA. Okay. So now, as we go through the drawing our right triangles, so in a right triangle, doesn't matter how you draw this now. So if this is my theta, and I have my right triangle, it's A, B, you can think of it as A, B, C, where C is that hypotenuse, because we also know that A squared plus B squared equals C squared. This is our Pythagorean theorem. This is a leg squared plus a leg squared equals a hypotenuse squared. So if A equals 8 and B equals 15, then we have 8 squared plus 15 squared equals C squared. We have to find that hypotenuse. We have 64 plus 225 equals C squared. 289 equals C squared. So the square root of 289 is 17, which equals C. So we know C is 17. And once we have our all three sides, then we really have all trig functions, all the ratios. sine theta, cosine theta, tan theta. Sine theta is going to be your opposite over hypotenuse, 15 over 17. Cosine theta, that's our adjacent over hypotenuse, because remember, we're going SOHCAHTOA. So cosine's adjacent, 8 over hypotenuse, 17. And tangent is opposite, 15 over adjacent, 8. And then cosecant theta, secant theta, cotan theta, it's going to be our reciprocals now. So 17 over 15, 17 over 8, and 8 over 15. So with right triangles, we can still find all 6 trig functions as we go through, as long as we can get our triangle correctly. And remember the ratio of the sides for sine, cosine, tangent, and which reciprocal goes with which, we should be able to get all 6 trig functions. So here's a right triangle. Here I'm just using this as my theta. So 7, 12. I don't know a, so it's a squared plus b squared, so that's 7 squared equals c squared, 12 squared. A squared plus 49 equals 144. A squared equals 95. So a equals the plus or minus the square root of 95. But because this is a triangle, we're not going with our xy being direction and stuff. We're going to use the positive one, the square root of 95. So sine theta, cosine theta, tan theta. Sine theta's opposite over hypotenuse, 7 over 12. Cosine theta, adjacent over hypotenuse. And tan theta's opposite over adjacent. But we have to rationalize this one. 7 square roots of 95 over 95. And the square root of 95 can't be simplified. It's 5 times 19. So there's no perfect square in there. So now if we do the reciprocals, cosecant theta, 12 over 7. Secant theta, 12 over the square root of 95, which is 12 square roots of 95 over 95. And cotan theta equals the square root of 95 over 7. So again, I'm going, before I rationalize it, that's what I'm using to use the reciprocal, so I don't have to rationalize it again. Now if we have A is 9, C is 41, so here's theta. We could change this. I mean, we could use it from this angle up here. But to this angle, it's the opposite, the adjacent, the hypotenuse is what you want to refer to. If A is 9, C is 41, so I'm going to have 9 squared plus B squared equals C squared. 81 plus B squared equals 1681. B squared equals 1600, so B equals 40. So this is a nice one. Sine theta, cosine theta, tan theta. Sine theta is opposite, 40 over hypotenuse, 41. Cosine is adjacent, 9 over 41. And tangent is opposite over adjacent. Now the reciprocals. Cosecant theta, secant theta, cotan theta. Cosecant theta is 41 over 40. secant theta is 41 over 9, and cotan theta 9 over 40. So other identities, these are called cofunction identities, and this is saying sine theta is the same as cosine 90 degrees minus theta. These are cofunction identities. Tan A equals cotan 90 degrees minus A. Secant A equals cosecant 90 degrees minus A, and our other ones. But if you really think of what this is saying, if I have a right triangle where if this is my angle A, then this, because these two angles are complementary, this is going to be 90 minus A. And if A, this is opposite, and this is adjacent, and this is hypotenuse to A, so sine is opposite over adjacent, sine of A is opposite over hypotenuse. Well, notice what the cosine of 90 degrees minus A is going to be the adjacent now, so this would be adjacent to this over hypotenuse. So that's really what this cosine is saying. Sine of one angle is going to be the cosine of the other angle. It's the cofunction because these are complementary angles. All angles add to 180 degrees, so if this is 90, these two have to add to 90. So if we're going to use that now, so here write each one as its cofunction. So again, to this would be adjacent, this would be opposite, and this is still going to be the hypotenuse. So you can see how if we did it with cosine of A is adjacent over hypotenuse, then that's going to be sine to get to this side over hypotenuse. So that's what that one's saying. So if we rewrite these now, this is going to be cosine. Sine of 27 degrees is cosine of 90 degrees minus 27 degrees. So this is going to be cosine of 63 degrees. So now if we do cosecant 50 degrees, it's going to equal its cofunction, which is going to be secant of 90 degrees minus 50 degrees, which equals secant of 40 degrees. Cosine of theta plus 20 degrees is going to equal sine of 90 degrees minus theta plus 20 degrees. Now be careful, make sure you use parentheses, because that minus, that negative, gets distributed through. This is going to be sine 90 degrees minus theta minus 20 degrees, which is sine of 70 degrees minus theta. Now some of these we can check. We can check the first two, but this one, because of that theta in there, we're not going to be able to. So now if you're using your calculator, now the first thing as you start evaluating on your calculators, you want to make sure you check your mode. Alright. So that mode, you have to be in degree mode. So instead of radian, we'll get to that when we get to chapter 7. But this is a degree, so go over to degree, hit enter. Then you can go second mode to quit. So we're going to plug these in now. So if we want, there's 3 buttons. So here's sine, cosine, tangent. So if I want to go to the sine of 27 degrees, remember my mode is degrees, so I can go find that value, sine 27. And now if I find cosine of 63, what these cofunctions are saying is those are going to be the same value. Now you have to be careful when you put cosecant in. Cosecant of 50 degrees. So notice sine, cosine, tangent. There are buttons sine inverse, cosine inverse, tan inverse. Don't mistake those for cosecant. That's if we're looking for an angle, we're going to find sine inverse, cosine inverse, tan inverse. To use cosecant 50 degrees, you have to go 1 divided by sine of 50 degrees to do your cosecant. And secant of 40 degrees is going to be 1 divided by cosine of 40 degrees is going to be your secant, and notice that those values are the same. So these are your cofunction identities. Now if we want to find one solution for each, assuming all angles involved are acute, what we're really saying is sine of theta plus 20 degrees or minus 20 degrees equals cosine of 2 theta minus 5 degrees. Well, because these are cofunctions of one another, sine and cosine, if we add this angle with its cofunction angle, what's a plus 90 degrees minus a? So a plus 90 degrees minus a is going to be 90 degrees. So what we're really saying, and again, so if I come over to here, you can see that up there. If I go a plus the other angle, 90 degrees minus a, we do get 90 degrees. Alright, because these a's would cancel. So when we're solving these now, so we're going to say theta minus 20 degrees plus 20 degree or 2 theta minus 5 degrees. These are actually, if we go back to our triangle, these angles here, you can also think of it this way, that those two angles are complementary angles, and two complementary angles have to add to 90 degrees. But if this was sine and some other than cosine, you wouldn't do it this way, because we wouldn't know. But these are the cofunctions, so we know that these are complementary angles. And that's going to equal 90 degrees, and now we just have to solve. 3 theta minus 25 degrees equals 90 degrees. 3 theta equals 115 degrees. Add 25 to both sides. Theta equals 115 degrees over 3. That's what our theta is. And if we check that, if you can see here, there is a glare. If we go sine, my theta was 115 divided by 3 minus 20, and I get 0.314. Doesn't matter what that value is, as long as when I go the cosine of 2 times 115 divided by 3 minus 5, that cosine should be the same as that sine. Same thing, tangent, cotangent, these are cofunctions. So it's 3 theta plus 6 degrees plus 4 theta equals 90 degrees. So 7 theta plus 6 degrees equals 90 degrees. 7 theta equals 84 degrees. Divide by 7, and theta equals 12. Now if you want to put this into your calculator, we have a button for tangent, so we go tan 3 times 12 plus 6, and we're going to get some value. Now how do we put cotangent into your calculator? You can't go that second tangent. That tan to the negative first is standing for an inverse tangent. So what you would have to do is go 1 divided by tangent of 4 times 12. And we should get that same value. So now, for exact values, if we're looking for the trig functions with exact values, it's going to be a 30, 60, 90, a 45, 45, 90, or our unit circle. So I want to go through this 30, 60, 90 degree triangles. So if we have an equilateral triangle, what that says is same sides and same angles. So this is 60 degrees, 60 degrees, 60 degrees. So I'm going to say that this side is 2t, this side is 2t, and this side is 2t. But the reason I use 2t is because I'm going to split this. So now if I'm looking at half of this triangle, notice that's a 30, 60, 90 degree, and I can find my height. So h, squared plus t squared equals 2t squared. H squared plus t squared equals 4t squared minus t squared from both sides. H squared equals 3t squared. Now take the square root. H equals the square root of 3t squared. H equals the square root of 3 times t. So what we have here is we really have the square root of 3t, but now notice how everything has a t in it. So I'm going to divide all these sides by t, and what we have is we have a 30 degree, 60 degree, 90, and if I divide 2t by t, I'm going to get 2. T divided by t is 1, and the square root of 3t divided by t is the square root of 3. And this is our basic 30, 60, 90 degree triangle. Now opposite 30 has to be the smallest side, 1. Square root of 3 is 1 point something. Opposite 90 has to be the larger side, which is 2. So opposite 30 is 1, opposite 60, square root of 3, and opposite 90 is going to be 2, or the hypotenuse is 2. So now we can use this anytime we have a 30, 60, 90 triangle. The ratio of the sides are going to boil down to a square root of 3, 1, 2 triangle. So now for 45 degree, 90, we'll do the same thing. If these angles are the same, then this side has to be the same. So I'm going to say t and t. So to find the hypotenuse, it's going to be t squared plus t squared equals, we'll say, h or c squared. So this is 2t squared equals c squared. C equals the square root of 2t squared. So c equals the square root of 2 times t. This is the square root of 2 times t. So now notice again how we have a t in everything. So this right triangle with 45 degrees, 90. If we divide t by t, we get 1. Divide t by t, we get 1. Square root of 2t divided by t is the square root of 2. So again, this is a basic 45 degree triangle. So anytime we have a reference angle of 45, we're going to be using a 45, 90. Anytime we have a reference angle of 30 or 60, it's going to be a 30, 60, 90 degree triangle. So these are basic triangles that you want to make sure you memorize the correct sides, 1, 1, square root of 2, and 1, square root of 3, 2. 1's opposite 30, square root of 3 is opposite 60, and the hypotenuse is 2 for a 30, 60, 90. Because then we're going to be using those right triangles to find the exact values. So again, if we're looking for the exact values, we're going to have a 45, 90, which is 1, 1, square root of 2. We're going to have a 30, 60, 90. Opposite 30 is 1, opposite 60, square root of 3, and that hypotenuse is 2. Or we're going to have our unit circle, because if it's a quadrantal angle, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. depending on if it falls in. So sine of 45, we're going to go to our 45, 45, 90. Sine is opposite over hypotenuse. So it's going to be 1 over the square root of 2, but we have to rationalize this, so this is the square root of 2 over 2. Sine of 60, we're going to go to our 60. Sine is opposite, so notice I'm going opposite of that, square root of 3 over hypotenuse. This is square root of 3 over 2. Tan 30, I have to go to my 30-degree angle. Tangent's opposite over adjacent, 1 over the square root of 3, which is the square root of 3 over 3. Secant 45 is equal to 1 over, or cosine 45 degrees. Or we can say, well, if cosine 45 degrees is equal to, got to go to 45 degrees, cosine adjacent over hypotenuse, 1 over the square root of 2, then 1 over the square root of 2, or the reciprocal of that, is going to be the square root of 2. Instead of saying it's adjacent over hypotenuse, secant is hypotenuse over adjacent, square root of 2 over 1. Cosecant is going to be the reciprocal of sine. So if sine 60 degrees, well, we have to go to 60. That's our square root of 3 over 2. This square root of 3 over 2. Then cosecant is going to be the reciprocal, 2 over the square root of 3, or 2 square roots of 3 over 3. And cotangent, well, tangent of 60 degrees is going to be opposite over adjacent, which is going to be the square root of 3 over 1. So cotangent is going to be the reciprocal, 1 over the square root of 3, or the square root of 3 over 3. So anytime we're looking for exact values, it's going to be using one of these pieces as we go through. So if we look sine, cosine, tangent, cosecant, secant, cotangent of 30 degrees. So again, using these three pieces, you know, your 45, 45, triangle, 30, 60, 90, or your unit circle, we can fill in this table. So sine of 30 is going to be 1/2. Cosine of 30 is going to be the square root of 3 over 2. Again, so how did I get those? Sine of 30 opposite over hypotenuse, 1/2. Cosine of 30 adjacent over hypotenuse. Tangent is going to be opposite over adjacent, so it's going to be 1 over the square root of 3, which is the square root of 3 over 3. And now we're going to flip. Cosecant's 2. 2 over the square root of 3, which is 2 square roots of 3 over 3. And cotangent is going to be square root of 3. Now if we're doing 45, sine of 45 is 1 over the square root of 2, which is square root of 2 over 2. Cosine is 1 over the square root of 2, which is square root of 2 over 2. And tangent is 1. How do we get that? Sine, 1 over the square root of 2, rationalize. Cosine, adjacent over hypotenuse, now rationalize. Tangent, opposite over adjacent, which is 1. And now I need the reciprocals. So this is going to be square root of 2, this one's going to be the square root of 2, and this is going to be 1. Now 60 degrees, sine of 60 degrees is the square root of 3 over 2. Cosine of 60 degrees is 1/2, and the tangent of 60 degrees is the square root of 3. Again, if I'm going back to this triangle, now I'm going 60 degrees, so sine is opposite, square root of 3 over 2. Cosine is adjacent, 1/2. Tangent, square root of 3 over 1. And now I need the reciprocals. 2 over the square root of 3, which is 2 square roots of 3 over 3. 2, 1 over the square root of 3, which is square roots of 3 over 3. Now if we're doing 90 degrees, So the sine of 90 degrees is 1. The cosine of 90 degrees is 0. The tangent of 90 degrees is undefined. Again, how am I getting that? I'm using my unit circle, 90 degrees. So remember, it goes cosine sine. So the sine of 90 degrees is 1. The cosine of 90 degrees is 0. Tangent is sine over cosine, so it's 1 over 0, which is undefined. And now the reciprocals, 1 over 1, 1, 1 over 0, undefined. And remember, this was really 1 over 0. So when I do the reciprocal, we're going to get 0 over 1, which is 0. So that's 6.1, using 30, 60, 90 degree triangles and the unit circles. We're going to be using a lot more once we get out of the first quadrant with these and reference angles in the next section. So I hope that helps with section 6.1.